All right, so here's part one for our study guide for the final. So this one is all about surface area and volume, and you're going to need lots of formulas from your formula sheet. So let's kick it off with number one. It says find the area of the figure. This is a regular polygon, so we, would use our formula. That is area equals 1/2 ANS, which stands for apothem, number of sides, and side length. So based on, that's the formula we need, then I know I need apothem, number of sides, side length. What I have given, I don't know the apothem, but I do know, so I'm going to skip the apothem for a minute. I'm going to plug in what I do know. Don't know the apothem. I know the number of sides is 6, because there are 6 sides to my hexagon, and the side length is also 6 down there at the bottom. So I just have to find the apothem. If I draw in the center here, and I create a nice triangle, drawing to the corners, the vertices there, then I can figure out the angle. We talked about this. If this hexagon was inscribed in a circle, then each one of these would be the radius, because this would touch the circle as it goes around, as it would touch the circle here and there. We would draw the circle all the way around. So those lines would be our radius. It's been a while since we've done this, so I'm just reminding us. So those would be the radius. We don't really care about the radius for this problem. We want the apothem. But what is helpful with that is that this in here is a central angle. And I can figure out what that measurement is by taking the total degrees in a circle, which is 360, and dividing it by how many sides or how many triangles I would divide my hexagon into, which is 6. So 6 goes into 360, 60 times. This is a 60-degree angle. Then, in order to actually make use of it, though, I want the apothem, which is the altitude. If I draw it from that center, I'm going to actually redraw that, because it should be right smack dab down the middle. There's the apothem. Well, it's closer, but okay, which splits the side here into 3 and 3. We said the whole angle was 60 degrees, which makes each piece 30. The apothem is the height of these two triangles here, which I call A. And then if you know your 30, 60, 90, this is a 30, 60, 90 triangle, you can easily find A. If not, you can use trig. We have the angle 30 degrees. We have the side opposite and the side adjacent. So we're looking for TOA, or tangent. Tangent 30 is going to equal opposite and adjacent. Opposite over adjacent, 3 over x. To solve this little equation, not x, I'm sorry, 3 over a, my adjacent, which happens to be the apothem. I'm going to make two fractions. I would cross multiply, do the love connection. So equal sign a times tangent 30. And then 1 times 3 is 3. Divide both sides by tangent 30. And that's where I would get A equals, and I need to do that on my calculator. Sorry, I don't know tangent 30 by heart. So let me grab my calculator here and do that math for us really quickly. So we have 3 divided by that didn't work out well. My apologies. Let's try that again. So we're doing 3 divided by tangent 30. I get 5.19. 5.196. Okay, so if I put that into my formula, 5.196, and then multiply it all the way out, so multiply it by 1/2 times 6 times 6, I get 93.53. It says round to the nearest tenth. So I look back and I would keep it the same because 3 doesn't tell me to go up. So 93.5. Don't forget your units. This is miles. Squared, excuse me. Area is squared. So this would be miles squared. All right, forward. Number 2, same basic idea here. Find the area. We're going to do that same process. So area equals 1/2 A times N times S. And I need again to find the apothem. I'm sorry, I need to know what I have. So first of all, if I go to fill this in, I know 1/2. I don't know the apothem. I know the number of sides is 7, and the side length is 7. Then I just need to find the apothem. I'll draw my triangle and draw in my apothem. There's my apothem. Now this time, when I do go to find my angle, I'm going to be doing 360 divided by 7 because I would have 7 of those triangles. So that gives me 51.43. That's a rounded answer. So I'm going to say 51.4. So, whoopsie, sorry about that. So that would be the whole angle, but then I have to cut that 51.4. I have to divide it in half. And I get 25. I'm having trouble saying my numbers here. 25.7. So the smaller angle in our single triangle here is 25.7. Then I also know my 7 gets split up into 3.5 for each smaller piece of that side. And once again, I'm ready to set up my angle. I have the opposite and adjacent sides again. So tangent or TOA. So tangent of 25.7 equals my opposite, which is 3.5, over adjacent, which is A. Then I would again put this over 1, cross multiply, do the love connection, draw your equal sign. So I have A times tangent 25.7 equals 3.5. Divide both sides by tangent 25.7. And I get A equals, and here we go back to the calculator. So let me see what I can do here. We have 3.5 divided by tangent of 25.7. I get 7.27. Then when I go to put that in, I multiply it by the other things in my equation, go back up to the area formula. So multiply by 1/2, multiply by 7, multiply by 7. I get 175. It says round to the nearest tenth, so I would have 178.2, which is slightly different than what you guys have. So on your thing it says 178.1. It's probably a matter of how I rounded, when I rounded, and how I put it in the calculator. So I could check it, but basically it's the same answer, and we are on our way. Number 3, find the volume of each figure. Round your answers to the nearest whole if necessary. So first of all, we need to know what shape this is. This is a prism. It is, we're asked for volume. So the volume of a prism is base times height, where the B, the capital letter, represents a calculation area of the base. The base in this picture is a pentagon. I think when we did it in class, we might have done it as if it was a hexagon, but it is a pentagon. It only has 5 sides. So to find the area of the base, the B, I would need the formula for a regular polygon, which is 1/2 ANS. And in this case, what I already know, I know the 1/2. They give me the apothem at 4.8. They give me the number of sides, which would be 5. And the side length, they also give me as 7. That would be this right up here. That's your side length. So then I would multiply all those out and see what I get. Give me a second to do that. So I get 84. Let me try that one more time, just to verify. Yep, 84. And so then I go and put that in my formula. Base is 84. The height for this is the distance between the two bases. So my two bases are the pentagons on the top and the bottom. Those are the unique shape that are across from each other. So the 7 is the height, the distance between those two shapes. And let me just clear that craziness out. Okay, so this one is the height. This one up here was the side length. All right, so I have 7. So I get the volume is 588, and this is feet cubed. And it's already rounded to the nearest whole, so we're good to go. Number 4, this one is a pyramid. So we would need the pyramid formula. So volume of a pyramid is 1/3 the base times the height. In order to do this, if I start filling it in, I have 1/3, but then I'm going to need the base, which again is area of the base. In this case, our base is a hexagon, 6 sides. It's a regular polygon. So we're going to need our area formula for a regular polygon. So to find, again, the area of the base, I would do 1/2 ANS. In this case, that is 1/2. They give us the apothem. That's this number right here pointing to this piece in our picture. So that would be 3.5. The number of sides is 6. And the side length they give us is over here as 4. So if I multiply all those together, again, give me a second to do that. I get 42. Let me just really quick verify. 42. So 42, and then times the height, that would be this number right here, showing the actual literal height from top to bottom is 8 kilometers. So we'll put that in and multiply all those together, and I get 168 kilometers cubed. Cubed again because it is volume. Hold on, that 168 doesn't look right. Really quickly, let me try that one more time. Oh, my apologies. I typed it in wrong. There we go. I thought that was not quite right. Not 168, 112. Got to type all the numbers in correctly. 112. Okay, next. Find the volume. This one is a cone, so we need the formula for the volume of a cone, which is 1/3 base times height. For this one, to find the area of the base, we need we need to know the area of a circle, because that's our base in this one, which is pi r squared. And we can fill our formula in right away. We have the pi r squared. The pi, we know the r is 5, and square it. So we get the base is, do 25 times pi really quick. I get 78 point, whoopsie, 0.5. Go and put that in my formula. 1/3, 78.5, and then times the height. So this was the height is here, gives us the literal height from top to bottom is 10. And that 5 in the picture, that was our radius. Anyways, so when I go ahead and multiply this, I get 261.799. When it says round to the nearest whole, so I want no decimals. Come back, honey. Uh-oh, what happened? Hold on, everyone. Technical difficulties. See if it's back to normal. It was not responding. Okay, so if I want a whole number here, I would be trying to cut off my decimal places. So I look back and I am going to move that up to 262, and this is meters cubed. All right, continuing along, find the volume again. This one is a pyramid, so we need to be on the right slide. There we go. Volume equals 1/3 base times height. So this time the base is a square, so we need to find the area of the base. So the area of the base for a square is length times width, which for a square, your length and your width are the same. So in this case, that would be 7 times 7, which is going to give us 49. So I have 49. Go and put that in my other formula. 1/3 49 times the literal height there, that's our h, is 8. And let me do that math for us on the calculator. I get 130.67. And this one again, it says round to the nearest whole, which means I don't want any decimals. So I look back and the 6 tells me to round up to 131. This would be inches cubed for volume. On to number 7, find the volume. This one is a cylinder. Our formula for the volume of a cylinder, the one that we gave you is, it should be volume is base times height, but I think we gave you this one, which is with the base part already inserted. So pi r squared h. So if I plug into that, I know pi. The r is given to me as 6. And the height is also given to me as 6. If I multiply that together, I get, hold on one second, multiply by pi, I get 678.58. And again, round to the nearest whole. So I look back and I will be rounding this up to 679. And this is kilometers cubed. All right. One more volume. Find the volume. This one I believe we did in class, but we'll look at it again. This one's a tricky for 2 reasons. We have a trapezoid, and also because that trapezoid is the base. So we're looking for the unique figure, that there are 2 of them connected by a rectangle. So the unique figure is the trapezoid. So this is a prism. We're going to use area equals base times height. That is the formula for the surface, not surface area, excuse me, volume. I don't know why I'm saying area, excuse me. Let me try that one more time. Volume equals base times height. There we go. Okay, so the base in this particular case is the trapezoid. So when I do area of the base, I need the formula for the area of a trapezoid, which is given on the formula sheet. It is 1/2 the height times b1 plus b2. So this is where it gets a little bit tricky because we haven't used a lot of trapezoids. So 1/2, that's no problem. The height for the trapezoid, I'm going to do that in a different color, is this guy right here. That's the height of our trapezoid, which is given to us as 1.7. Then the next thing is the bases, B1 and B2, are the bases for the trapezoid. Those are the sides that are parallel. See, that came out not so pretty. We'll try that one more time. So the sides that are parallel are this side and this side. Those are 3, and then we steal the other side from the back, which is 5. So I would have 3 plus 5. Then when I solve that, I get 1/2, 1.7 times 8. And put that in my calculator. And I get 6.8. Then that's the area of my base. Go back to my formula. I have 6.8 times the height. So the height of the the height of our prism, which is what we're finding the volume of, the height of the prism is the distance between the two bases. So the two bases, there's the other base in the back. So the distance between them is actually this guy. So it would be 6. Then if I multiply that out, I get 40.8. And this one, again, round to the nearest whole. So this would be, look back, I'm going to round up. So I get 41, and this is kilometers. Sorry about that again. This is kilometers cubed. All right, so on to the back side. Finding the surface area, now we jump to a different set of formulas. Surface area for a prism. This is a prism. That's important we know. It's a prism. So my surface area formula says the perimeter times the height plus 2 times the base. So we have 2 things we have to find here. We need the perimeter. The perimeter means the distance around specifically the base. So here's one of our bases, our hexagon. So if I walked all the way around that base, how far did I walk? Well, I did 8 plus 8 plus 8 plus 8 plus 8 plus 8. Or we could say 8 times 6, which is 48. So my perimeter is 48. The height of the prism is, again, that distance from the two bases. So I'm outlining the base on the bottom. Okay, so the distance between the two bases is 9. That's my height. I'll go and put that in my formula. 9 plus 2 times the area of the base. So here we have area of the base. My base is a hexagon, so I'm going to use the regular polygon formula, A and S. In this case, I know 1/2. They gave me the apothem, which is 6.9. The number of sides is 6, and a side length is 8. That's my side. All right, so then I multiply all those lovelies together, and I get, let's see. So 1/2 times 6.9 times 6 times 8. Try that one more time. Not convinced I did that right. 1/2 times 6.9 times 6 times 8 equals 165.6. Let me do it one more time to verify. 1/2 times 6.9 times 6 times 8. And I typed it in wrong. So one more time. 1/2 times 6.9 times 6 times 8. 165.6. Perfect. So 165.6. And I multiply that by 2. So this is 331.2. 48 times 9 gives me 432. Add it together. I get 763.2. This one says round to the nearest hundredth if necessary. This one I don't have a hundredths place, so I could add in a 0 if I need to. And then this is yards, and since we're doing area, it is yards squared. All right, find the surface area. This one is a pyramid, so surface area of a pyramid formula is 1/2 P L plus B. So when you do this one, be careful. The perimeter is talking about, again, going around the outside of the base. So when I go all the way around, I've done 4 plus 4 plus 4 plus 4, or 4 times 4 is 16. The L stands for slant height, which is this one right here, the slanted part. So this is our L, 6.3. Then the final thing we need is the area of the base. So for this one, the area of the base is going to be length times width, or in our case, those measurements are the same, 4 times 4, and we get 16. So simplify that, go through and add these up. I have this first part gives me 50.4 plus 16. So I get 66.4. And again, it says hundredths place. I don't have a hundredths, so I can put a 0. And then this is miles squared. On to the next one. Find the surface area of each figure. So round your answers to the nearest hundredth, if necessary. So this one, I'm going to, the shape we have here is this one is a prism. So we're going to use our surface area of a prism, which is perimeter times the height plus 2 times the base, 2 bases. In this case, since this is actually a cube, all sides are the same. So you could argue about which one is the base. I'm going to use the actual bottom here as my base. Since, again, all the sides are the same, so you could kind of pick which one. The perimeter going all the way around would be 9 plus 9 plus 9 plus 9. So that would be 9 times 4, which is 36. So I have 36. The height is 9. Then I have 2 times, I need the area of the base. In this case, again, length times width, but those measurements are the same, 9 times 9, so I get 81. When I put those numbers into my calculator, let's see what we get. I get 324 and 162. Add them together, I get 486, and this is inches squared. All right, find the surface area of each figure. Round your answers to the nearest hundredth if necessary. So this time we have our last surface area of a cone. The formula for that from our formula sheet is, where's my cone? There it is. We have pi r times the slant height plus pi r squared. So here I would need to make sure I have everything I need as I go along. Pi, got it. The r is 3. There's my r. Let me write that a little more clearly as an r. Then we have the slant height, remember, is the actual slanted part of our cone or pyramid, in this case 11.4. Then plus pi times, again, the r, which we said was 3, and squared. This one's going to take a little bit more calculation, so bear with me. I have 3 times 11.4 times pi, so I get 107.44 plus pi times 3 squared, which is 9. I think this was, I missed it. I'm sorry. Let me type that in one more time. My apologies. Pi times 9, I get 28.27, not 128. I'm going to erase that. 28.27 plus the 107.44. I get, need a pen here. There we go. I get 135.71. And this one we're supposed to round to the nearest hundredth. I didn't put any more decimals, so mine's already rounded to a hundredth. On the answers I gave you, it says 7.2, so don't mind that. It's probably because I rounded early. And then this one would be squared. All right. Number 13, we have scale factors. We're given the scale factor for a small and a big shape. So small to big. And we're told these measurements are for the small figure. So we have two tasks. We're going to find surface area and we're going to find volume. For surface area, we start with our scale factor, which is 6/7. And since it's area uses the exponent squared. So we square both of those and get 36/49. We then take our new scale factor, 36/49, and we build a proportion with the surface area from the small figure. So we have our setup small to big. So I do small to big, which we don't know. Then I would cross multiply, do the love connection. I get 36x equals, I'm not sure what 49 times 144 is. Let's find out. I get 7,056. Then I would divide both sides by 36, and I get x equals 196. This would be our surface area, so this is going to be miles squared. Then we go to volume. We start with that same scale factor. Since volume uses the exponent of a 3 or cubed, we are going to cube our values there. And this gives us 216 over 343. Once again, we take that scale factor and we are going to set up a proportion with our information from our small figure. So 2376 over x, cross multiply, do the love connection. So I have 216x equals some really big number. Here we go. Whoa, go back. 814,968. Divide both sides by 216. And I get x equals 3,773. And this would be miles cubed. On to the next one. This one's basically the same kind of setup. So we have, again, this is from the small figure. This is going to be our small and our big. We're looking for surface area and volume. For surface area, we start with the scale factor. For surface area, we square it. So I get 1/36. Then we take that and build a proportion with the actual surface area of the small figure, which is 7, over x, the big one, we don't know. Then cross multiply, do the love connection. I get x equals 36 times 7, which is, go back, to, go back, honey, 252. And this one, x is already solved for, so this is my surface area, 252 miles squared. Then we go to volume. We start with the scale factor. For volume, we're going to cube it, and that's going to give us 1/216. We then take that and build a proportion with the actual volume from our small figure, which is 11, over x, the unknown big volume. Cross multiply, do the love connection, and we get x equals 2376. And that one again, x is already solved for, so this is miles cubed, and we are done. Nicely done.